Aggregate roots. An aggregate root is a single root used to represent multiple prefixes, which helps decrease the number of static roots advertised by your device, thus decreasing the size of the routing tables maintained by neighboring devices. It also helps to hide specific routes in the local routing table. As I just mentioned, an aggregate root consists of multiple prefixes, and these prefixes are called contributing roots. And at least one of these contributing roots needs to be present for the aggregate to be active in the routing table. Aggregate roots have a preference of 130, but the most important thing to realize is that there is no option to configure a next hop. You must configure an aggregate root as either reject or discard, and then this is passed on to the neighboring device through root policy.
If you're enjoying the content, please consider subscribing, as 86% of viewers aren't currently subscribed.
This means that if there's a prefix in the aggregate that a neighboring device is trying to reach that doesn't actually exist in the root table as a contributing root, the device drops the packet and sends back an ICMP message. So this aggregation video is going to be a lot more theory than some of our previous videos, because a lot of the aggregation terms that I've seen are aggregating roots in BGP, and BGP is something that we're going to cover a bit later on. But that's not to say that we can't do the aggregated roots video and find out how we would calculate an aggregated root. So let's have a look at our diagram. And now we're seeing that we would be aggregating three networks, which is 172.16.2, 4 and 6. So let's write those out into a notepad. We have 172.16.2, 172.16.4.0, and 172.16.6.0. And we want to find out what is the aggregate of those roots. First things to notice is that all of this is happening in the third octet. So the first octet is /8, then /16, and then we start with the third octet. So what I would do, I would write at 128, 64, 32, 16, 8, 4, 2, and 1. And above that, I would say this would be a /17, because we know we've gone into the third octet, so /16 has gone already. /18, /19, /20, /21, /22, /23, and /24 for the last one. And we're trying to calculate the first one, which is 2. So to get 2 from this, it'd be 0, 0, 0, 0, 0, 0, 1, 0. This equals 2. 0, 0, 0, 0, 0, 1, 0, 0. This equals 4. And then we've got 0, 0, 0, 0, 0, 1, 1, 0. And this equals 6. Now what we need to do, we need to actually find the first section which has all the numbers the same. We're looking at this one here. And this basically gives us our answer, because we can't use this one because there's a 0 here and 2 1s, so the bits are different. And here there's a 1 and a 0 and a 1. We can't use this because it doesn't cover them, so it has to be this side. So the first one that we've got with all the bits the same is this one. The network that we would want to use is 172.16. We know that the first two octets are 172.16. Then we'd have 0.0/21. And this will be our aggregate root. So let's go and do this configuration on the actual router, and then let me see if I can show you the trick I was talking about. I've got R1 opened up, and what I'm going to do, I'm just going to configure these roots as additional roots on the loopback. 172.16.2.1 slash, let's say slash 32. We're going to do the same for 4.1 and also 6.1. We can see that we've added these 3 roots here now. Let's commit that. And let's see if that's been advertised across to R2. So we can see that they've been advertised. We've got 172.16.2.1, .4.1 and .16.1. So what is the trick that I would actually do to find out what is the aggregate of these roots? I said that my aggregate is 172.16/21. So if I jump onto R2, run show root, and I just put in 172.16/21, you can see that these 3 roots appear. That means that the /21 is the correct aggregate root for those 3. Now, if I was to do a different one like /22, only the 2.1 would come in. And this is because on a /22, only what's on the right of it would come in. And 2 is the only one. 6 covers 4 and 1 to make 6. So our root of 172.16/21 is the correct aggregate for all of these roots. That's just a little trick that I use to verify and validate that the aggregate root that I'm using is correct. That's all I've got on this video. Let's move on to the next one.
It's question time. Question 1. In Juniper Networks routers, when configuring an aggregate static root by using the aggregate command, which statements accurately describe the behavior and configuration options for aggregate roots? A. The preference option sets the preference for the aggregate root but does not impact the contributing specific roots. B. The summary-only option generates a summary root without including the contributing specific roots in the routing table. C. The discard option causes the router to discard packets destined for the contributing specific roots while allowing packets destined for the aggregate root. D. The AS set option includes all the AS numbers present in the contributing roots within the AS set attribute of the aggregate root. The answer is A. Question 2. In Juniper Networks routers, when configuring an aggregate static root using the aggregate command, which statements accurately describe the behavior and options for aggregate static roots? A. The summary-only option generates a summarized prefix but does not include the contributing specific roots in the routing table. B. The discard option causes the router to discard packets destined for the contributing specific roots while allowing packets destined for the aggregate root. C. The generate option automatically generates the contributing specific roots based on the aggregate root and its associated prefix length. D. The AS set option includes all the AS numbers present in the contributing roots within the AS set attribute of the aggregate root. The answer is A. To get the complete question banks for all the JNCISENT videos, drop us an email at info@rittercoach.com.